The next couple of screencasts are going to kind of show you the difference between different data types. In this screencast, I'm going to show you the difference between what we call univariate and bivariate data. There is another data type that's multivariate data, just FYI, but we're just going to primarily be focused on univariate and bivariate data. So univariate data represents observations or measurements on only a single characteristic or attribute. For example, a police officer might be performing a survey of car speeds on a particular stretch of road. She is only interested in the speeds of cars and nothing else. So it's just a simple survey, univariate data. Speed in miles per hour is the only thing that she is interested in. So on the right here, I have the data that the police officer collects. We have a bunch of speeds rounded to the 10th place, and we can put it into something known as a histogram. This is really the only way to visualize univariate data. You're sort of just preparing a distribution. On the y-axis here is the frequency, or the number of observations that lie in a particular bin. So on the x-axis here, this is the miles per hour, but we've taken all of our data points, our observations, and sorted them or put them into these bins. I'll talk more about this when I talk about histograms, but for example, the bin center of 30 really lies, that's all the observations between 29 and 31. So that's sort of the bin boundaries. When we make a histogram, we plot the bin centers, and that's pretty typical of histograms. So we take all of our data and kind of put them into different mailboxes, if you will, with a center of 28, 30, and so on. And this is what we get. And for univariate data, really the only thing you can do is kind of visualize the distribution of the data. Bivariate data, in contrast, represents observations or measurements on two characteristics or attributes. In the previous example, the police officer might also be interested in making a correlation between the time of the day and the speeds of cars. So now we're looking at two different variables or measurements. We're looking at the time of day and the speeds of the cars. The raw data is over here on the right. So she records the time and the miles per hour. So we can visualize this by putting the time of day on the x-axis and then the speed on the y-axis. The speed, by the way, a lot of times when we plot XY data, x-axis is usually the horizontal axis, the y-axis is on the vertical axis. The x variable is oftentimes known as the independent variable, and then the y variable on the y-axis is typically denoted as the dependent variable. The data could look a little bit different. Perhaps she collected the following data. You see that there's clearly a correlation here. You have high speeds earlier in the day, and you have lower speeds in the middle of the day, and then you have higher speeds in the later in the day. If we go back to the previous data, you see that there's not really any strong correlation between the speed as a function of time of day. So these XY plots for bivariate data really tell us if there's any correlation between the two variables. We would say that there's very little correlation for these data shown here, but then here you might these might be correlated. For example, we could put in a model equation where we can predict the speed based upon the time of day. Another example, here we have univariate data. We're just collecting a bunch of burritos and weighing them. This was an actual experiment I did with a bunch of students a couple years ago. We have the weights of all of the burritos, and then because there's only one thing we're measuring, really the only way we can visualize this is as a distribution. So we can kind of make these bins. The bin widths here are 60. The bin boundaries, for example, for this second bin would be 530 all the way up to 590. So any burrito lying between 530 and 590, we counted in that second bin. So we can create nice histograms for univariate data. However, if we were to correlate this to the restaurant, so we have Illegal Pete's, that's a restaurant here in Boulder, Qdoba 1, 2, and Chipotle, and we perform 5 replicates there, we can put together a bar plot here where we've got on the x-axis the categories. In the next screencast, I'll talk about categorical versus numerical data. We have the categories here, the different restaurants, and then on the y-axis, we have a continuous variable. And that's the average weight that I'm plotting in this bar plot. Those bars, by the way, are known as error bars, and they sort of show you the variability among replicates at each of those restaurants. So this is another example of bivariate data. So hopefully you learned a little bit more about the differences between univariate and bivariate data in this screencast. Thanks for watching.